Welcome to the REMMI project. My name is Frederick Bott. This is a quick introductory video to tell you what the project is all about and how you can get involved should you wish to back us on Indiegogo, in which case I look forward very much to working with you. Thank you. Okay, so a little bit more about me. My qualifications are BEng, Honours, Electrical and Electronic Engineering, and Master of Science, Concurrent Engineering, and also a Chartered Engineer. My experience is 20 years working in industry with companies such as BAE, Thales, EADS, Celex, and most recently Cobham. My job with Cobham is model-based design. I'm a systems engineer, model-based systems, and I work in the R&T department of Cobham at the moment. I've been there for a couple of years and enjoyed working on programs such as Astrea, in which we work in partnership with BAE Systems, Bristol University, Thales, Kinetic, and a few other people involved on the Astrea program. The Astrea program is a program to get UAVs into civilian airspace. And so it's a civil program, and it's expected that those UAVs would be for civil application. So, current employment, just mentioned that, Cobham. REMMI company is me, myself at the moment. I would expect to be taking on help where it's needed. At the moment, most of the work is involved in modelling and simulation, a little bit of asking for, phoning up and asking prospective sites that they may want to host the REMMI UAV. I'll tell you more about that in a second. And that's about it. REMMI also has a website, remmiuav.com. And there is a company in the background, REMMI Limited, which so far has not traded, but may be brought in to encapsulate the company eventually. Because from experience, I know that this type of business, being as complex as it is, needs to have a limited company to properly handle its affairs. It can't really be done by an individual, because sooner or later there's going to be employees, and then it gets very complicated. So, that's in reserve. The REMMI project, the what, why, how, where and when, how does it work, what's it all about? REMMI, Remote Me UEV and Services. So basically we are offering, or looking to offer, services which involve enabling people to use their internet PC to connect to remote UAVs at sites of interest and to be able to experience that site as if they were there in a sort of virtual reality type experience. And that might include the use of, well, it will be designed to include the use of Oculus Rift VR type headsets. That gives you a far greater experience on the remote site than does if you just use a computer monitor. However, it will be capable of doing so just with a computer monitor for minimal sort of consultancy type access. The UAV development will be carried out mostly by myself. It will be open source type development. We'll be using as many open source existing pieces of modelling and code that we can find that are useful, and as we make it, as I develop that, it will be posted on probably GitHub in an open source way. It will be, during this process, the main method of doing the business will be model-based systems engineering and model-based design. The reason I'm saying this is because I know the power of this, having used it in industry on and off, and also having worked in industry where they don't use it. And it's plain to see that if you use MBSE, it's far more efficient than any other method, and in fact actually enables a single person to put together a project of this complexity, as you'll see, whereas normally it would take a company with a few people, quite a few people in it. The other thing that we need to consider in the project is remote site agreements acquisition. So that means contacting various sites of interest and getting agreements that they may wish to host REMMI UAVs at their sites. And this sort of thing could be a quarry, a volcano, an old farm even with a barn house. There's many different things that people might wish to just go and have a look. The idea would be that they would pay when they log in to the internet using a website and software that we'll provide, which would be charging them per visit. So it would be a small amount of money, maybe £5, £10, to go and see somewhere that's quite exotic and would cost an awful lot more, if not impossible, to go there in person. That site would have one or more REMMI UAVs at it, into which people can log into. The REMMI UAV, when it's at the site unused, would be on a charge base and just waiting for people to log in. When a user logs into the REMMI UAV, it automatically then takes off and behaves in that site as though it was in a simulated environment, but actually it's in a real environment, and it would be controllable in the same way in a simulated environment via the forward and backward arrow keys. And we would also need to have a program, which is mentioned in the next bit of REMMI pilot training, which would be in the simulated world. So, and the theory being, if you can fly a simulated REMMI UAV in the simulated world, then you have all the skills you need to do it in the real world. The real REMMI UAV will be restricted not to be able to collide with things or people, and it will have zones which are programmed per site, no-go zones, which may be available at particular times of the day or might not be available at all, depending on the sensitivities of the site. I.e., like some sites will have toilets, we don't want UAVs flying in there. Some other sites might have living places for family. Again, they want their own privacy, so there's certain rules that have to be built into the UAV. And the other thing is to satisfy the UAV legislation, which is likely to happen in the future, it will need to be completely locked down in a way that nobody can abuse it in any reasonable manner. The why, the need for remote UAV capabilities. There's many applications apart from just tourism. Security companies, remote consultants, all sorts of different people who would be able to use such a service. They could run their own software and buy the UAVs and run a completely private network that way, or they could be a remote site of attraction, somewhere that people would like to go and visit, in which case we would supply them with leased UAVs and pay them a fee for having the UAVs there. In other words, they get paid for having their site of attraction, and we would charge the customer using the software on the internet. So that's the way it works. The need for MBSE training. In industry, we still see much of it done in a very inefficient way, so we know that in general industry could benefit a lot from MBSE, model-based systems engineering, and also people, individuals, can run their own projects like this the same way as I'm doing at the moment, if they've got the right background, the right knowledge. And also engineers who have never used MBSE, maybe have heard about it, but they've never actually came into contact or they understand really what it's about, then they could do being trained on that as well. So we're intending to offer throughout this program MBSE training, and that will be the main bread and butter pledge reward of £1 for the entire training courses which arise. The training material which is generated through this work. This will be a sort of program where you get a very detailed view of all of the development work that's carried out and where that relates to model-based systems engineering texts. Say, for instance, the OCSMP, which is the Object Certified Systems Management Professional qualification. It's a standard recognised qualification for MBSE professionals. That training, this would go some way towards gaining that training, because the relevant sections of the required knowledge there will be identified and traced to the work that's carried out here in this programme. The how: UAV development, concept modelling and requirements engineering. The concept modelling will be done in SysML, and requirements engineering also in SysML. Those things we call part of the specification model. That term comes from a document that legislates airborne software, and the aircraft industry at the moment adheres to that. The actual section of that document is DO 331. If anybody wants to have a look at that. It's the model-based supplement to DO 178C, and in there you've got these two model types defined: the specification model and the design model. As I say, in our specification model, we will be doing it in SysML. UAV development, physical chassis and custom parts. That will be the physical chassis and custom parts, things like the plastic propeller caps and things like that, plus the physical chassis will all be 3D printed from 3D models developed in 3D modelling software. UAV development, physical system and controller will be done, that's part of the previous thing I was talking about there. The UAV development, physical chassis and custom parts is all part of the design model. So the 3D modelling work and development of the 3D printer output is all part of the design model, which is traced back to the specification model. The specification model is agreed with your stakeholders. So basically, all of you folk who have backed the project, you are the project stakeholders. All of your inputs and all of your questions will all be put into that part. And the system design part of the system then is designed to meet all of those requirements. The UAV development, physical system and controller will be done in MATLAB Simulink, and that's an environment where we use mathematical models to model the system behaviour, the detailed model behaviour, and finally at the end of that we will generate code from that system which goes straight onto hardware. And the hardware that we're talking about is not expensive. The target hardware at the moment is expected to be a Raspberry Pi. And there happens to be a tool set in MATLAB Simulink which works very well for that. It's been used a lot of times now. We expect that to be the method of producing the code. Excuse me. REMMI UAV pilot training, mentioned earlier. How do we do it? We have a sort of obstacle course with checks in the virtual environment, which people will be required to negotiate with a simulated REMMI UAV. And on their successful completion of that course, they will receive a virtual certificate which they can present when they first go to fly live real life REMMI UAV via the internet, and they will be allowed to take that flight with their pilot training certificate, virtual certificate. Model-based systems engineering training, as I mentioned earlier, it will be dished out as we cover the ground. We'll be outlining all of the model-based systems engineering concepts that need to be that you need to have knowledge of really to understand. And all of the model-based concepts that we will be covering will be trained. We'll dish out training on those prior to actually presenting them in the course and the work of the development. So people will learn the concepts they need to know in order to understand the work that's been done. Remote site agreements and REMMI UAV leasing and purchasing. Again, I described that earlier. It's basically just how to, in the case of some sites, we'll be leasing to the site. In the case of other sites, such as security companies, they might want to buy their own and run their own private network. Funding is Indiegogo. Initially, I'm expecting to be raising funds just to get going. That means enough funds to buy the software, the initial software that's needed, plus maybe a down payment on the 3D printer. Those things are significant expense, which is really for it's for the business to find the funding for. And once we get those things, we are well on the way to coming around, getting onto the real development work. The where development and initial prototypes manufacture will be done here. I expect there's not going to be huge quantities, just enough to satisfy a very small market. I'm expecting to offer some of these prototypes maybe as rewards for pledges of significant pledges. The amounts there have still got to still need to thrash out, but you'll see it on Indiegogo. Development and initial prototypes manufacturers is here. Model-based systems engineering training will be done via the website remmiuav.com. All of the materials that are generated during the work of the development of the REMMI UAV will be posted on that website in a section which is accessible by members with passwords, and everyone who donates the minimum donation of £1 or more will receive a password, a personal password to access the website and check out the materials there. Also there, we'd say, probably on Indiegogo is the best place for feedback, for people to feedback comments, concerns, questions, suggestions. All will be fed into the requirements and the stakeholder concerns part of the systems model. The systems model includes all of these things that are outside the actual UAV. This is what we're talking about, model-based systems engineering. It takes in the whole life cycle of the product, not just the build of it. REMMI UAV pilot training, again, where does that happen? It happens in the virtual world. The funding, where does the funding happen? On Indiegogo. When? The project plan. We have a project plan. Quite look at that. Project plan. Just bring that in. And we've got some Gantt here, a Gantt chart which charts out the expected progress. At this moment, we're on this red line here. So the things that are underway are things like Kickstarter project fund gathering. It says Kickstarter here. I should clarify, the project was initially launched on, it attempted to be launched on Kickstarter, but they decided that they needed to see a hardware prototype. Now, the nature of this project is it's model-based systems engineering. The whole point is to avoid the expense of hardware prototypes. That's what model-based design is all about. Getting it right first time, because you've simulated it to death before you start making hardware. So there's no point in having a prototype. It's a waste of money and time. So rather than try to knock them up something and say, there you go, there's a prototype, I'll give you a Raspberry Pi, would have proved nothing, and we'd be lying really, because the prototype is not going to be developed until production time. So better to change to a more amenable environment, which we believe Indiegogo to be. Remote sites agreement seeking, that's about this bar here. We can zoom out here. Move that. So the remote sites agreement seeking, the length of that bar is pretty much the whole length of the project, and it stretches from January this year through to April next year. So that whole time we're going to be open to receiving and making agreements with various sites of attraction. It's a kind of chicken and egg scenario. How do you get credibility enough to get an agreement with a reasonable site of attraction without having a product? And like vice versa, how do you get you backing for a product that doesn't exist yet and you don't have any sites of attraction? One, without the other. So they both have to be done at the same time, really. And I would expect to have a few, maybe half a dozen, maybe a dozen, between 6 and 12 sites there, hopefully, by the end of March next year. So the next one, concept stakeholder analysis. That's when it starts. Starts just about now and finishes about here. The reason it looks like it started there, this is a baseline that was put together a few weeks ago before the Kickstarter delay. So it's moved a little bit because there was a delay there that was not expected, and by this time I thought we would be underway. The training school virtual chassis is done. You can see that in the virtual world here. We've got my avatar there, and we've got a virtual chassis just here. When we move that around, that's basically been generated in the software Blender, which is a open source 3D modeling software. Oops, I just closed that. 3D modeling software, which I need to open that again. The reason I need to keep that open in the background is because this computer, for some reason, requires to be loaded with something fairly taxing on the graphics cards in order to keep working, otherwise it blue screens. And the problem there is, I think it's probably the fan of the computer. It needs to be working in order to keep things cool enough to work. And when I don't have something loaded on the graphics, then it overheats and goes into blue screen. Not your problem, but I need to keep an eye on it. Right, manufacturing process implementation. I'm not going to go through all these tasks one by one because we'll be here all day. But you can see the general idea. Also, the most detailed project plans are the ones that go most badly wrong. The more detail you try to put in it, the more it will go wrong. It's just life. The best you can do is schedule things in a way that they're less likely to land on a critical path if they happen to go less than as planned. As a wise man once said, I think it was Francis Bacon, somewhere about 1690 or something like that, he said, if a man's happy to go on uncertainty, he'll always end up with certainty. And if a man's only happy to go on certainty, he'll always end up with uncertainty. Like I say, the more comprehensive you make the project plan, the more you're trying to start off with certainty, and the more likely you're going to end up with uncertainty. So, a bit of philosophy there, for what it's worth. Okay. The last point in this actually happens to be a picture of it's a modelling view. It's called a mind map, and it's using one of the modelling tools that we're proposing to use for the concept modelling. I won't go into all the tool sets here because again it's a long task, but I will provide another video which goes through the process of that will be followed for the development of the detailed model. I'll give you a quick look at requirements stuff in SysML. If we go to the model here, look at the systems engineering model, requirements model. Here. We've got the system specifications which are presented graphically, and in the actual specifications, this is just a template, but I'll use the same thing. I just rename these things and extend it all. This will be the system's requirements, and they're derived from the system stakeholder concerns, and we define the stakeholders in a use case model as actors. So the REMMI stakeholders are the project backers, the REMMI UAV buyers, the REMMI UAV users, the UAV standards agencies. They are all stakeholders, and all of their concerns are fed into the requirements. So bring it on, people. If you're interested in backing and putting your input to the project, please do. Again, I'm looking forward very much to working with you, and it's going to be a lot of fun, this project. So see you soon. Thank you.